guys, welcome to our YouTube channel Tenacity Online. Myself J. Chandraseshan. So in the previous class we have discussed about problems related to differentiation. In this class we will be discussing about acceleration. So let us discuss acceleration now. So acceleration is defined as the rate of change of velocity with respect to time. See, A is equal to limit delta t tends to 0. This is change in velocity with respect to time. That is equal to differentiation of velocity with respect to time. So whenever they are saying acceleration, it should be clear that it is instantaneous acceleration. Likewise, velocity, acceleration also has types, but when they say you acceleration, you have to be clear that it is instantaneous acceleration. Okay, acceleration is a vector quantity. So I mentioned an arrow mark above A. A denotes acceleration. So SI unit of acceleration is meter per second square. Why meter per second square? What is the SI unit of velocity? It's meter per second. Right, meter per second. And again, the SI unit of time is second. So that it will become meter per second square. So meter second inverse square. So this is the SI unit of acceleration. So its dimensional formula is m power 0, L power 1, T power minus 2. Because it has a unit which calculates length and it has a unit which calculates time. It doesn't have a unit which calculates mass. So majority of the kinematical problems or kinematical terms doesn't include mass. Hope you are clear with this. And acceleration is a vector quantity. That means acceleration has both magnitude and direction. So I will give you an example related to acceleration. You consider that a driver who is on bike is traveling. You consider that he is traveling with 10 meters per second throughout his journey. So if he is traveling with the 10 meters per second of velocity throughout his journey, there is no acceleration because there is no change in velocity. So if the magnitude of velocity gets changed in his journey, we say that journey to be accelerated. I hope you are clear with this. Not only the change in magnitude of velocity, we call it as acceleration. We also call the change in direction of acceleration to be the acceleration. So you consider a man moving from initial point A to final point B. Okay. So suppose you think that he is moving with velocity of 10 meters per second, or whatsoever velocity he can move. So if he is traveling from A to B and it is his journey, and which is traveling in 10 meters per second throughout his journey without changing his velocity at any time, we call it to be uniform velocity, as I said you in the velocity and speed concept. So now when you consider at time t is equal to 0, is starting with 10 meters per second, and at t is equal to 2 seconds, his velocity, you consider either it as increased or decreased, we call it as accelerated motion only. Okay, so when this man comes to point B, if its velocity rise by 1 meter per second, you say 11 meter per second, let us consider. So the change in velocity is 1 meter per second in 2 seconds. So its acceleration will be 0.5 meter per second square. So in 2 seconds he is traveling with the acceleration of 0.5 meter per second square. That means in 1 second the velocity is getting changed by plus 0.5 meter per second. That is the idea which you will get while seeing this acceleration number. Okay, this is acceleration when there is change in the magnitude of velocity. I will give you one more example, that you consider a circular journey. You consider a man is in point A, and let the center of this circular path be O. So let us think that he is traveling in the circular path with uniform speed, that is 2 meter per second you say now, and at every instant is traveling at 2 meter per second. At every instant is traveling at 2 meter per second. Will you say that this motion to be accelerated motion or non-accelerated motion? I think you will say it as non-accelerated motion because the velocity is not changing in the magnitude. As I said, it is a vector quantity. If any of either magnitude or direction changes, we tend to call it as accelerated motion. So initially it is moving with minus 2 j cap meter per second. Okay, so now it has changed its velocity to 2 I cap meter per second. So now you are noticing that the velocity is getting changed, so that this motion is said to be accelerated motion. Any circular motion is said to be acceleration as the direction is getting changed. If you consider the whole journey, when it comes to this point, its displacement is 0, velocity is 0, acceleration you will tend to say it as 0. But when you consider from point A to point B, it is accelerating. From point B to point C, again it is accelerating. Here j cap, it is in the upward direction. Here again you will say it to be changing its velocity by minus 2 I cap. So it is an example for accelerated motion. So any accelerated circular motion is said to be accelerated. So this is the part of acceleration. Let us discuss some golden points or key points and some types of acceleration. Okay, let us see some key points related to acceleration. The acceleration is due to the change in either magnitude or direction of velocity. As I said, in the circular motion, when the particle is traveling with the same magnitude of speed or magnitude of velocity with 2 meter per second, the direction keeps on changing. So when the direction keeps on changing, the acceleration must also be changed, because it is a vector quantity and which it depends on direction also, and it also depends on changing magnitude also. I have given the examples related to this too. Okay. So if the speed of the particle is increasing with time, we call it as positive acceleration. If the speed of the particle is decreasing with time, then we call it as negative acceleration. Okay, because I will show you now. Suppose you consider this 1D motion. Let you consider initial and final points. Let the velocity be point and the velocity be 2 meter per second at the final point. Now you calculate the acceleration. Acceleration is v2 minus v1 by t. So let you consider time to be 1 second. So 2 minus 3 by 1, that is equal to minus 1 meter per second square. So now as the velocity is getting decreased, the acceleration is negative. If you consider here the velocity to be 4 meter per second, then the scenario will change. So 4 minus 3 by 1, that is plus 1 meter per second square. I hope you are clear with this. If the speed of the particle is increasing or decreasing with time, then we say acceleration to be positive or negative respectively. This is the second key point related to acceleration. Now the third key point is, the above statement is independent of the choice of reference frame. When the velocity is increasing, what is the matter of reference frame? If it is increasing, then the acceleration will be positive. If it is decreasing, the velocity is decreasing, then the acceleration will be negative. So it is independent of the choice of reference frame, right? So that is mentioned in the third key point. So let us look at the fourth key point. For positive acceleration, the velocity vector and the acceleration vector are in the same direction. Okay. For positive acceleration, the velocity vector and the acceleration vector are in the same direction. Suppose you consider a body. Let us say the velocity is 2 meter per second. If the acceleration is 3 meter per second square, if you calculate, so nothing to calculate, if you say that when the velocity and acceleration are in the same direction, you can say that acceleration to be positive. When the velocity vector is towards right, 2 meter per second, and acceleration to be minus 1 meter per second square. Now, if for positive acceleration, the velocity vector and acceleration vector are in the same direction, and for negative acceleration, the velocity vector and acceleration vector are in the opposite direction. That is true. See, if the acceleration is minus 1 meter per second square, the velocity is 2 meter per second. After t is equal to 1 second, the velocity decreases to 1 meter per second. from 2 meter per second. So you can say that acceleration and velocity vector, when they are in the same direction, the acceleration will be positive. When they are in the opposite direction, the acceleration will be negative. That is mentioned here. So these are the key points related to acceleration. You have to be very precise and accurate about these points. And let us discuss now with the types of acceleration. Those are instantaneous, average, uniform, retardation, etc. Let us see the types of acceleration now. So there are 4 types of acceleration, in which I am discussing 3 and one more will be discussed next. So first let us discuss the first type of acceleration, that is average acceleration. So average acceleration is defined as the change in velocity with respect to the total time taken by an object to cover the journey. So average acceleration is equal to change in velocity by total time taken by an object. So that is equal to v2 minus v1, which is written in the vector form, by t2 minus t1. So while calculating this average acceleration in one dimension, no need to write arrow mark, because you are calculating it in one dimension and vector form doesn't affect you that much. So let us discuss an example related to average acceleration. To consider a 1D motion, I have discussed already the example while saying the key points. So still then I am telling the example for you to get grasp to the concept which I am teaching now. When we discuss some problems related to the concept gets more clear when we discuss problems. So I am giving you a situation of one-dimensional motion in which at the initial point the velocity is 5 meter per second at t is equal to 2 seconds, and at the final point the velocity of an object is 7 meter per second at time t is equal to 4 seconds. So now we have to calculate the average acceleration. So average acceleration is, so generally we denote average acceleration in this manner, okay, that is average, final and initial. So we will put a bracket like symbol to represent average acceleration. So average acceleration is equal to v2 minus v1 by t2 minus t1. So that is equal to 7 minus 5 by 4 minus 2. That is equal to 2 by 2. That is equal to 1 meter per second square. So this is an example of average acceleration. I hope you are clear with this problem. So generally they will not ask this easier problem in any of the competitive exam or board exams. This is just an example to understand the concept clearly. Okay. So let us discuss the uniform acceleration. Uniform acceleration is, the definition is given here, if the velocity either increases or decreases at the same rate throughout the motion, then we call it to be uniform acceleration. Hope you are getting the point which I am telling in this definition. If the velocity either increases or decreases at the same rate, that means, so take a one-dimensional motion. I will draw still more properly. Okay. So suppose if you make it intervals, 1 second, 1 second, 1 second intervals, 1 second intervals you make. So initially let the acceleration be, velocity be 5 meter per second. So if the acceleration, there is no use of mentioning velocity while discussing uniform acceleration, when at each and every interval of time, if the acceleration is either decreasing by the same rate, so 1 meter per second square, 1 meter per second square, 1 meter per second square, that means if in this interval, if the acceleration is 1, it has become 2, it has become 3. So the gradual increase in the acceleration in specific time intervals is called uniform acceleration. Or else I will tell you one thing, that if you find the average acceleration of the path of the journey, and at every intervals of that journey, if instantaneous velocity, instantaneous acceleration is equal to average acceleration, then you can call it as uniform acceleration. Okay, this is about uniform acceleration. So next, let us discuss retardation or deceleration. Retardation or deceleration is the negative acceleration. Let us see how. If the speed is decreasing with time, then we call this type of acceleration to be retardation or negative acceleration or deceleration. If the speed is decreasing with time, I will give you an example. Generally, as we are discussing one-dimensional chapter, I am always giving you the examples related to one dimension. So let the acceleration be 2 meter per second square in the initial point A, and at the final point B, let the acceleration be 1 meter per second square. So when the acceleration is getting decreased with time, you call it as deceleration or negative acceleration. So generally in the question when they ask deceleration, you no need to mention negative symbol. When they ask you the acceleration, you have to specify negative symbol. So here the acceleration is 1 minus 2 by t. So you take t to be 1 second. So 1 minus 2 is minus 1. So acceleration is minus 1 meter per second square. So when they ask the acceleration of this journey, you have to write minus 1 meter per second square. Otherwise, if they are asking specifically that to calculate deceleration or retardation, you have to just write deceleration to be just 1 meter per second square. It is understood that when they are asking deceleration, it is minus. So this is about retardation or deceleration. Let us discuss the fourth type of acceleration, that is instantaneous acceleration, which is very important. So let us discuss that one. So instantaneous acceleration is defined as the acceleration at a specific or particular instant of time. Suppose you consider a one-dimensional journey. So it is the body is starting at t is equal to 0 second, and let us consider this to be initial point and a final point. When they ask you to find the instantaneous acceleration at second, that is when t is equal to 2 seconds, what will you do? So you have to use the concept of differentiation to find out instantaneous acceleration. Okay. So instantaneous acceleration is limit delta t tending to 0. Why we are writing delta t tending to 0? Because we are calculating the acceleration at a very small interval of time. So when delta t is tending to 0, we will get a velocity, we will get a change in velocity. That change in velocity we will call it as acceleration, instantaneous acceleration. So that is about instantaneous acceleration. And now let us discuss something special. So you learn that velocity is ds by dt. That is differentiation of displacement with respect to time is velocity. And you also learned that acceleration is dv by dt. So if I want to write acceleration in terms of displacement, how shall I write? So we can write it as a is equal to d square s by dt square. That is double differentiation of displacement is acceleration. How it means? So velocity is the differentiation of s, right, with respect to time. So acceleration is the differentiation of v with respect to time. So when you are differentiating v, in place of v you can differentiate ds by dt, no? So that means you can differentiate d by dt of ds by dt. So that will be, I will show you, a is equal to ds by dt. Instead of differentiating velocity, you can differentiate the change in displacement. That is d by dt. To show you properly. So a is equal to ds by dt. So you consider this to be velocity now. So you are differentiating velocity with respect to time. So that is d square s by dt. So this is important. And see here, acceleration is the differentiation of velocity with respect to time. In the previous class we discussed about chain rule. So if I apply chain rule in which u to v, that means I said in the chain rule I use u, du, no? So I am using here ds. So I can write a is equal to dv by ds into ds by dt. So what is ds by dt? That is velocity. So velocity into dv by ds. So this is one more very important concept, formula. Okay, when velocity is given in terms of t, that means when velocity is given in terms of t like this, something like this, you can directly differentiate velocity with respect to time. When velocity is given with respect to displacement, if they are given velocity with respect to displacement, you can differentiate this one and you can multiply with v. Okay, I hope you are clear with this. So when the velocity is given in terms of function of displacement, you will use this formula. When it is given in the function of, when the velocity is given with respect to the function of time, you will use this formula. So this is the instantaneous acceleration. I hope you are clear with this.